Kim, are we rounding up the people that they're coming, are they? Okay, good. We'll find out whether I was supposed to be instructions and I was supposed to begin afterwards, I think.
Do you know if my slides come up here?
Yes, they will.
Excellent.
So for the speakers, I've got some 5 minute, 3 minute, 5 minute, 2 minute, and 1 minute, and then stop. Okay, so I'll give you a reminder.
Yep.
Yeah.
Thank
You may as well get the first one up on the screen now. Just, yeah. The last session was facilitating that via No, I'll do it during, but then I'll hold other questions at the end to keep the time.
If you do it during, I've just got to go and meet Simon McManus. It's about the only time I can do it, so I won't be able to moderate your questions.
I'll about it.
So you'll be alright, you'll just scroll and you'll work it out?
Yeah.
Okay, sweet.
Yeah, we're a small group.
But there's a small group, I doubt you'll be heaps of them.
Yeah.
So, yeah.
We'll start.
Excellent. Okay.
All right, it's my pleasure to chair this last session of the first day. I hope you're enjoying your day. We're very privileged to have Stacey. Stacey's from Australia, and Stacey's from ITS Australia, so it's great to have our counterpart organisation from over the ditch to come and join us, and Susan in the audience as well. Thank you, Susan. Good to see you. So it's a pleasure to introduce Stacey Ryan, who's going to be speaking on changing the way we move for good. We have 15 minutes per presentation, a little bit shorter than that, about 12 minutes, leave a few minutes for questions. And then we'll also, if there's time, we'll keep the time, so there might be people travelling between the sessions. So I'll keep to that. And then if we have some extra time at the end, we'll have an open Q&A session for after that. So those in the audience, please do put your questions on Slido so that we have them, and put the name of the person who you're wanting to answer the question. And we'll monitor those and keep them going as we go through. Okay. Over to you, Stacey. Welcome to Auckland.
Thanks, Jack. Thank you all. So this is a bit of a bad pun, changing the way we move for good. Obviously, we'd like to change the way we do things for good permanently, but this is not the case. So we're working through a bit of research that we've done, and I'll get to that in a second. But for good is the way that we want to change the transport network, and the way that people are able to action it, engage with it, and utilise it in the time that they need it, and for the lifestyle that they look at working through. So as Doug said, we're ITS Australia. I'm pleased to see a lot of our members here at T-Tech as well. We've got a large collection of folks across the transport technologies sector. You might see some of yourselves up there, and representing multinationals and startups and all the state government agencies as well. So we've been pleased to be able to be part of an iMove CRC collective in Australia for almost 10 years. And while the majority of the work that we do is focused on technology, and safety is the North Star for all of our members and ourselves, sustainability and network management and productivity is a critical part of the work that we're doing as well. So while technology is our focus, better understanding how humans interact with the transport network and what we can do to support their engagement with technology is a critical part of the work that we do. So while we are seeing the numbers of road trauma go in the wrong direction, we're also seeing emissions go in the wrong direction. So we partnered up with the federal government in Australia, the Queensland Department of Transport and Main Roads, and the University of Sydney, along with iMove, to better understand what we might be able to do. So as I said, this number's not budging too much. The 30% is around internationally averaged on the emissions for the transport sector. It's not going down, it's averaging out. So we want to work out a way to manage to be able to reduce that impact. So Carol mentioned this morning. This is the first iMove project that we did almost 10 years ago on mobility as a service, when that was the new big thing, to better understand how Australians might work with mobility as a service and what it might be able to do. So we surveyed around 4,000 Australians to understand what their thinking of mobility as a service might be and how they might be able to interact with it. Two key findings we had: people have no idea how much transport costs. They completely ignore the fact that their cars cost them a huge amount of money. That's invisible to them, and they think the transport costs that they pay at the, you know, the bus stop or the ticket, although it's a bit more transparent now that we can contactless pay, they think that's much higher. And we developed a series of personas as well to map out the likelihood of people to be able to want to subscribe to mobility as a service. And the key focus there was people that are pretty price sensitive, folks that are already using active transport and motorcycles, and then people with mobility challenges, wheelchair users and other mobility aids, very keen on the idea of something like mobility as a service. And then it obviously went down through different people and modelled out the opportunities for them to utilise it. But we were really interested in those two key findings. So as, again, I'm going to be saying, as Carol said quite a lot, it's nothing about technology or all of the brilliant policy interventions we can come up with unless we're engaging with the people and better understanding how they work, they understand things, and they operate. So the next major piece of work we did was on community transport, because we talked to a lot of our members, and community transport is what we call a wicked problem. It's massively increasing, as we see. The older people in Australia and internationally are going up, younger people are going down. That demographic pyramid is in the wrong direction. How can we manage to implement better positive outcomes for older people and people with disabilities as they age? And internationally, we have policies to age in place. We want people to be able to stay in their own homes, to get support, and for that they require transport and other support. And the key finding for this one is, although a lot of people didn't believe us, the return on investment for community transport is enormous. For every dollar you put in, you can get potentially up to $40 benefit because of all the health impacts, the health benefits, and the societal and quality of life benefits that you get as well. So then that one led us to another thing that was happening at the time, which was the idea of shared vehicles. It was big in New Zealand, actually. You were one of the first people to do what was called undocked or free-range car share. So everyone was very excited about this potential, but as we've seen with bikes and scooters, it can have negative externalities. People that use it love it. People that don't, it's very visible to them, and they're very challenged by it. So we did a major piece of work with RMIT, better understanding what this might look like going forward in the future. So all of which to say is that a lot of these challenges, we've done a lot of research on them to better understand what can be done. There's a lot of data underlying the implementations of opportunities, but we still have traffic, we still have congestion, we still have emissions going up. So that's when we get back to this behavioural change for sustainable transport. Moving back to that qualitative work, we surveyed again. So starting with the University of Sydney with this literature review, getting an understanding of the models through which we look at transport planning and the interventions that we can design to better implement interventions for people to get better outcomes. So this is modelled on the reduce, reuse, recycle. So avoid, shift, improve. Avoid is something like the 15-minute cities. And that's another driver for this research. As we were working through it, there was this massive conspiracy backlash to the idea of 15-minute cities and ultra-low emission zones and all of these other government interventions that just make sense from a planning perspective, but were seen to be negative for some reason. So getting an understanding from the human nature side of things, why people were resisting to those kinds of things. Shift and improve. So shift is obviously getting people from their vehicles into active and other transport modes like public transport, and improve is usually the most expensive bit. So that's service improvements, network improvements, and technological interventions that give people better opportunities to change their modes. So these are the other ones. We were working from the top down. Obviously, governments and other network managers do the capacity creation and network management side of things. We were looking at better understanding what that behavioural change and other opportunities for moving people into different modes. And so this is the matrix that they developed, kind of like a heat map that says from a short to a long time period and from high impact to small impact. The idea being that this would develop a toolkit for developers, employers, local governments and state agencies to model different outcomes and say, okay, we want to put a bike lane in, we're going to lose some parking spots, who will that benefit and who would lose out? And what would the costs be and what would the impacts be? So taking all of that insight and the analysis from ITLS, we then interviewed some subject matter experts, people that work at the front lines of these things, disability activists, government agents, transport providers, and people from overseas as well. Just to get a better understanding of their experience with some of these interventions, so they know they work, they know they don't work, and then that took us through to the survey structure. As you probably know, designing surveys is really tricky. People don't lie as such, but self-reporting can be difficult for people to remember how much they travel, why they travel, how they travelled. So it was designing a pretty complex survey around this concept of windows of change, like different times of life, job change, employment status, moving home, change of life, babies leaving home, and taking them through a series of discrete choice questions to get a pretty definitive answer. And coincidentally for us, a lot of this is around price sensitivity and better understanding what the charge model might be if they want to change from a current system to a road user charging. We didn't use the phrase road user charging, but it's enabled us to produce a couple of papers on road user charging built on this data. So again, as Carol said, personas play a large part of better understanding how we can model these data. So they've done 3 streams here: urban strivers, which is the highest socioeconomic group; settled simplifiers, sort of a middle-aged cohort with kids that are pretty established; and dynamic jugglers, often, oh no, it's the other way around. Settled simplifiers, often at home, pensioners, retired, and then dynamic jugglers, people that are struggling with a couple of kids and different jobs, maybe a couple of jobs. And so then work through then trips by purpose. It's obviously a big one, especially when it comes to charging and time of day and amount of times that they're on the road. And obviously the urban strivers are very much focused on commuting. Settled simplifiers, I think that the way that they work with them on better persona nomenclature, because it's hard to say. Dynamic jugglers do more trips with more trip chains, so complicated trips that would be hard to replace. And so then a sample of packages, initiatives. So across about 70 life changes, they drilled that down to about 25 critical ones. And then across those critical life changes, they identified these initiatives that could be supported by these particular personas. So essentially enabling people in decision-making areas the opportunity to map, okay, this is the intervention that we want to see. We would like to see more people on this kinds of public transport and in this demographic. What could we do to enable them to do that? Would that be talking to employers? Would that be with developers? Or that directly to the community to encourage them to swap out their existing, maybe more intensive, congestion-based traffic options into something like a public transport option, shared vehicles or active transport. So across the key findings, employer actions will play a huge part in driving these initiatives. Developers, again, but less so. That's more long-term as well. That's sort of baking in sort of transport packages into new developments, into greenfields and brownfield developments. Improving public transport accessibility and travel times, obviously. And the price point was pretty prevalent, but one of the big things that's happening in Australia in particular is a couple of natural experiments that we can test this on. So in Queensland, we've got 50-cent fares. In Victoria, it's half-price fares. And in New South Wales, they've capped all of the weekly public transport fares to $50. So we can start to map out to see how much that price sensitivity really does impact on usage. Some of the the negative externalities is the increased amount of electric and fuel-efficient vehicles can increase the amount of vehicle kilometres travelled just because it's easier and it's not at the Bowser as expensive to drive. And the increased amount of online shopping and click and collect has increased the amount of vehicles moving on the network as well. So getting a better understanding of, especially when we're talking about emissions, the sort of that scope 3 emission question. So who's responsible for the emissions when it comes to these benefits for customers, but they are causing increased emissions in people's neighbourhoods and communities. And obviously the parenting and caregiving phases, you know, that's where it's very difficult to relinquish a car, but what services can be provided to limit people's need for a second car or a third car even, because that's the kind of goal we want, to keep people at single car families rather than triple, quadruple car families. So I can't leave with my boss here without a couple of ads for ITS Australia. So we just did a recently very successful study tour in Japan, and we were lucky enough to take a couple of your colleagues from New Zealand Transport. Had a great almost week there, talking to colleagues in Japan, visiting transport management centres, and this replicates a study tour that we did in Dallas the year before, and we're looking to do one in the UK next year as well. So if you have any interest in doing that, let me know. And for all of you that have papers in this conference, I can't encourage you enough to, if you want to visit Melbourne next year for our Global Summit in September. And in the following year, we're privileged to be able to work with the TRB and host the International Symposium of Freeway Operations, Freeway and Tollway Operations. So that's also in Melbourne, but in May the following year. And for all of you transport geniuses that are working on major projects, our awards are a major part of our year, and nominations are currently open. So please don't hesitate to put in an abstract or a submission. Thank you very much.
Kept very well to time, Stacey. And we've got a small audience in here, and haven't seen many come in. So I'm going to start, before you run away, I'm going to ask her, maybe if you can stay here because we want to record questions as well, so that'd be good. So maybe given the size of the room as well, we've got a couple of minutes for questions. If you have a question, please raise your hand and we can, I can repeat that so that we can get it recorded as well. But I'm going to ask a question first in regards to sunken asset costs of owning a vehicle. How much does that make, do you think, a decision making in regards to people having that 92% when they're not using the vehicle, etc., but that stops them from changing behaviours?
It's huge. Like the invisibility of the cost, like it was around $10,000–12,000 a year that the vehicle costs them, that they have no concept of, you know, depreciation, insurance, maintenance, etc. So if there was a better understanding of how much that vehicle costs them from, you know, the initial payment down, then realising that that's an asset. Like I'm pretty sure in New Zealand it's the same as Australia. The second-hand car market is just going through the roof as well. So these are assets that could be beneficial as just selling them if they've got other opportunities. But people don't like to get rid of something once they've got it.
Yes.
But if they knew it was costing them, then that would be...
That's right. And keeping that vehicle for the 1–2% of the time that they may want to use it.
Yes. Yeah. It's very... The vehicle manufacturers, God love them, they did a really amazing marketing job 100 years ago by selling the idea of freedom with a vehicle, but...
A costly freedom.
Yes.
Another question in regards to the carrot and stick and incentives, disincentives of demand management. How palatable is the Australian market to having policies that are fairly strong levers to try to get them out of their vehicles?
Sadly, not very. Yeah.
Similar to New Zealand.
Where we did have some requests around some policy interventions after, you know, the war and the fuel shocks, and one of, you know, the recommendation was just lower speed limits. And unfortunately, it's a really tough bill. We're getting more and more academic and other public research, and that's been presented to the public rather than in academia, saying how beneficial lowering speed limits is. But yeah, it's a tricky pill. Mm-hmm.
All right, put your hands together for Stacey. Thank you very much.
Thank you.
We will see one question's just come in. We'll hold that to the end and we'll come back to that. So I'd like to invite James Young and Hanwai Peng up to the podium here, who are from Engineering X, and they're going to be speaking on rethinking brownfield road design from manual CAD workflows to constraint-based automation workflows. Welcome to the podium.
Thanks, Doc.
Good to see you. Some ex-students of mine.
Welcome, everyone. My name is James Leung, CEO and co-founder of Engineerix. Alongside with me, I've got CTO, co-founder of Engineerix, Han-Wei Peng. So, before we dive into the topic today, rethinking brownfield road design, I would like to ask two questions. Have you ever been in early design phase? Can be concept design, scheme design, where you have a lot of complex site constraint conditions, and you simply just can't fit in all the engineering requirements from your client. How often do you deliver fully to the time, cost, and scope? That's the first question. Another question is, how often is CAD software and modeling software actually resolve and help resolve effectively, efficiently of the problem I mentioned in the first question? If those questions sound familiar to you, you've come to the right place, because we basically have a solution for you. From manual CAD workflow to constraint-based design. So, a little bit of a background from me and Han-Wei. We are founders of Engineerix. Our mission is to transform and accelerate roads infrastructure design in APAC by providing automated infrastructure platform for engineers, government agencies, and all the engineering end users. I've been fortunate enough to be a transport engineer and a project manager at the same time, delivering concept, scheme, pre-implementation, implementation to construction in brownfield and greenfield project. Those projects can be pending project. I've been fortunate enough to be one of the project manager there, Riverlink, and then multiple Auckland transport project makes me really fully understanding the context in the brownfield and greenfield. Same with Han-Wei, he's an automation engineer by heart. He has been in the workflow of greenfield and brownfield, understanding and providing innovative solution for different clients. So that makes us have one vision in here, is to provide cutting-edge solution to the client, engineer, when it comes to providing more value for money, more efficient delivery in design and delivery process in New Zealand. So what is the problem we are facing? We want to phrase that as a manual design process of infrastructure. So below is a typical sort of process that engineer follows when there is nothing about the improvement. And what's the first step engineer will go through? As an engineer, I'll be very interested to understand what is the role involved. I want to go on site to look at the trees, to look at what footpath there is, and then I want to go to Auckland Council GIS, some software platform like that, to measure and understand the road width, average road width, whether there is a footpath, and then understand if there is any utilities around the site. And then, I will then form some sort of design cross-sections, understand the road constraint, look into the standard involved, multiple design cross-sections, and I will propose that to my client. Client normally pick up multiple of those design cross-sections. Engineer then start to use the CAD software or modeling software to form up multiple initial design drawings. That is the moment when engineers try to fit in the design cross-sections into the drawings and find out there are a lot of pinch point and locations that simply just doesn't fit in the road. Some of the area of the road will be wide enough to fit the design cross-section. Some of it is just not. So in terms of those pinch point, engineer then check the design requirement, make some sort of suggestions of this departure from standard, and then make some trade-offs to decide whether we add a speed table or not. Is it a cost constraint? Do we have enough cost? This is the process we call value engineering. So, but the process of value engineering is manual and iterative. Why is that? Because clients simply want to give you feedback about the design you have made. They want to take your design to public consultation, get the feedback from public. They then go through internal design review process, give you feedback. So engineer tends to take those feedback, update and iterate drawings. And this is simply just then to provide a few options. Why is that? In the time of months to years, a few options. It's because due to how constrained a brownfield environment can be. Because something changed, simply a GIS input change because of the site survey data can change how to design. how the drawings would be. And also, it's because of the manual CAD workflow that engineer needs to follow. And then, after that process, multiple times of iteration, engineer then gets to the final design and cost estimate for the client. That's the time actually the client receives the deliverables. What if I tell you that there is a platform, there is a software that can give you all design cross-sections automated, design drafting is also automated, vehicle tracking is automated, network design, roundabout design, network multi-traffic phase analysis, all can be automated in one platform. We want to introduce you AutoRoads Design. This is a design platform that takes all the GIS data that engineer will start a project and simply take those input, automate design cross-sections, all the available ones. Based on different roles, we'll have different set of design cross-section. Engineer pick one, design cross-sections, and then overlay and optimize into the role you're designing for. And safety element like speed table, right turn bay can be simply drag and drop in the model space. You can see when you expand, you add a right turn bay into the road, all the side road curves, intersection corners automated together. Another example would be the roundabout. You're dragging the roundabout in the intersection. You see the blue lines at the new curb lines, all automated, pushes to the side. And all the surrounding green sort of hedge is the vehicle tracking. In a roundabout design, we have all the vehicle tracking automated wrap around the central island, making engineer really easily see the pinch point, understand the site, and make design decision. Whether we have a bus to be design vehicles, we can automate it. We have a car simply, or delivery van as design vehicles, we can automate it accordingly. So no drafting required. So bring me to the next sort of comments. Every constraint affects engineering decision. Think about a right turn bay, different width, the road will have to be widened differently. Speed table, if it's a Swedish type of speed table, normal speed table, even a speed hump, there's different width requirement. Widen the road differently, affect different utilities. And the position you position there, the speed table will also affect how the vehicles might come in and out of the driveway. And simply a bus box, putting a bus box into different, adjacent to different driveway might cause coordination with the property owners and so on and so on. So every constraint affects engineering decision. AutoRoads Design take all these constraints and it is a coordinated system that consider every single element in here. We know that we move something, adjacent would have to provide spatial requirements and enough sort of width. So this is a coordinated system. You don't need to go back to AutoCAD, go back to open rows to then send your drawings into different places to get what you need. This is one show-stop platform that you can get your course, you can get your design, and we are not talking about minutes, we're not talking about months, we're talking about minutes and days, and your client will get all this design information in the earliest phase, so client can make most informed decision about whether a project can be delivered from the start or not. So one of the driving factors in our software is called vehicle tracking engine. And I've got Han Wei Peng in here, CTO of us, that talked a little bit more details about how vehicle tracking works in our automation software. Han Wei, hand over to you.
Thank you, James. So when we think about vehicle tracking, we think about swift path checks around these vehicles on the road corridor. But I want you to think about what if in a brownfield context, is there a harder problem to solve to enable the system to work? If we think about vehicle tracking in a brownfield context, we think about vehicle tracking through multi-obstacles where we have to avoid multiple islands, multiple clearances, and various curbs along the way. So for example, in this roundabout that you see, we see that there are multiple ways to actually go through the roundabout. With our innovative solution, we provide vehicle tracking where we can avoid the circulating roundabout and we can update it speedily in real time. What does this mean? Well, this means that in comparison to AutoCAD, where we use static vehicle tracking, where we have an individual tracking profile that's not tied into or integrated with any sort of systems, we're looking at manually having to track through an iterative process to enable a design. What we have provided now is an integrated system which include tracking as part of the customization process, and engineers is able to update the items interactively to provide the real-time information about where the design can be better and in which way we can improve the design very fast and very reliably. And this enables engineers to design with confidence that the vehicle tracking has been taken into account of. Now I'll pass on to James.
Just seeing the time limits. So just to conclude what we bring to you guys today, Engineering X is striving to provide a solution for all the engineers and the end users here to deliver better solution, better options, better value for client through providing a lot more options, not just multiple options in the traditional design phase, but we're providing 10, 20, 30 design options in minutes and days rather than months to just multiple options. So with that in mind, we would like to thank everyone for listening to us and really thankful that both Hanwei and I come back to present to our university, to our previous lecturer, and to you guys. Thanks.
Thank you for keeping to time. We're running a little bit tight, but I'll ask one question. Is there a case study you have already implemented this design software into practice into New Zealand real-world projects for Auckland Transport NZTA to provide its robustness and validation?
Yes, we have. We've been in pilot and proof of concept engagement with the leading agency like Auckland Transport and international consultancy to validate our software. So positive result has shown. And for example, one of the case study is an Australian project where they took our software just to automate intersection design in minutes. So those are the results they have then export and provide to the client, and positive feedback come back. And obviously, this proof of concept and pilot engagement is ongoing. So there will be more case study coming in the future very soon for public to see.
Maybe one other question. There are already several AI-assisted design tools that allow users to enter a prompt and have an AI agent generate the design automatically. What advantages does your software have over these other tools that have been developed?
What I've observed is that there are a lot of plugins in the existing software, whether it's in the AutoCAD, whether it's open roles. People integrate AI solution into efficienting the process. But there is not yet one software that provides every single deliverables that client and the engineer wants, whether it's design cross-sections, whether it's design drawings, and vehicle tracking. So everything is integrated together as one process tool for engineer to use, which is our cutting edge than all the softwares.
Great. We'll put your hands together for our two speakers here, and I'm sure we'll have some time maybe at the end to follow up on some questions.
Thanks, Doug.
As well. So thank you. Come up, Harris. So it's my pleasure now to introduce Harris Chowdhury from Unix Traffic, who's going to be speaking on future-proofing New Zealand's transport network with modern OMCS innovation. Welcome to the podium. Give your hands together for Harris.
I just need help maybe. Okay, good. All right, thank you everyone for staying back. I think appreciate whoever stayed back at this late hour. I'll introduce myself, Harris Chowdhury. I have been working in Sydney industry for a while, delivering different tunnel projects. Today I will be representing Unix traffic to demonstrate what we have developed in the past few years and what technologies we have adopted to future-proof the OMCS to make sure it's scalable, reliable, and continue to meet the safety requirements for any project. So for people who are not aware what is OMCS, in Australia, Operations Management Control System is a single pane of glass where you can monitor a bunch of parameters in the tunnel, in bridges, in different or road projects. I mean, bear with me, this is just a sample of what systems I am showing here. So in different project to project, you can find many more systems that needs to be integrated. That's what we call OMCS. In general, any OMCS system is there to prevent chaos for the operator, so he can, and these are some silent features that an operator can monitor. These are very basic ones. Obviously, system to system or customer to customer, we expand. Health monitoring of devices, risk management, event information of what's happening on the field, event representation on the GIS, alarms, very prominent one, and similarly some reporting for data-driven decision, and the one that is more, I think, very used is incident management. So any system we build, we try to make sure this is delivered, and I think that's the purpose of this presentation, to show how we ensure that we can still adapt by maintaining these items. So the OMCS solution serves cities as well as highways, bridges, and tunnels. The opportunity is to continue to expand to all these areas plus more, but our focus is mainly just on these for now. So one of the main things that we have to consider in any design and development of this OMCS is the end customer. So it's not just the operator in the control room, it's the user that that is basically who's using the roads, some long distance users like trucks and stuff, the technician who is working in the field. They all need to work in harmony, and the system OMCS is the one that provides that harmony, reliability, and makes sure that everything works seamlessly. There's no downtime as well. Well, whatever architecture we take, these are the fundamental requirements we need to make sure that we are delivering. So reliability, I just want to highlight here that it's never going to be reduced. The requirements is going to keep on coming stringent. System scalability, as I mentioned earlier, more and more as we are progressing, system scalability is required. We want more things to be introduced and still wants the systems to be expanding. Similarly to like amount of integrations we need to do will never reduce. It will keep on increasing. So here the question becomes like, what do we mean by, or why do we want the OMCS to be modernized? Well, simply put, I can simply put it in 3 terms. The number one is the dynamic traffic and user demand. As the population is increasing, the demand is increasing, the use of technology is increasing, and we have to make sure all those technologies work in harmony with the strict safety compliant requirements. We have to ensure we are providing support for ventilation systems, fire life safety systems, and typical lane control systems that's part of any transport software. And finally, the digital dependency. So as we are moving, integrating more and more software, basically the inherent risk of security and incompatibility, these things gonna come in, so we have to make sure that we are adapting. That's where our solution basically comes in. That's where the question is that from why do we need to move from legacy OMCS to ensure that we are addressing these rising safety expectations. We are ensuring to meet the dynamic traffic demands, evolving cyber threats in the operational technology space. And because of one of the fundamental one is that previous legacy systems, they are hard to change. If you have to move on, then you have to most likely move the whole system to a newer version of it. So coming to the approach. So the approach that we're going to take is modular, adaptive, and resilient. OMCS is now essential, therefore, not just an option that we should bear in mind. So quickly go through the key salient features of the innovations that we are taking. They're like we are, in our modern platform architecture, to make it resilient, scalable, and secure, we are adopting the self-contained system architecture, basically decoupling the UI, logic, and data. Adopting the Kubernetes-based platform solution, which helps us scale and recover or roll out these things using the latest DevSecOps tools. Ensuring cybersecurity by design from the beginning, because, like I said, integration, there's always going to be some challenges with different integration factors. We need to make sure from the very beginning we are considering the cybersecurity. And first, and last, the most important one is to give a unified user experience to the operator. We need to have a centralized, like a single front end, which can show, which is easy for the user to operate. So just to give you a high-level introduction based on time we have, basically in every monolithic previous application has these 3 layers. They all are modular inside it. But when you need to move from one place to another, you have to bring the whole thing most likely. And there's very hard limitations for you to upgrade certain module and still make sure that compatibility is there. So to solve that, what I was referring to self-contained system is we have broken down the entire system into functional blocks. That's what you are seeing as a verticals on the right. And we break the functions into one simple application, like alarms will have its own layers, user interface, business logic, and database, which basically helps us that, okay, if you want to improve the alarm feature for certain users, then we don't have to update the rest of the system. System is still able to work together with the fundamental core, but we can change this solution. There's some other benefits that we get. For example, now we are not dependent on a single programming languages, which is one of the key blockers for our software development, that our solution is always based on one system, one language system and a language framework. And we can also now integrate more resilient systems like WinCOA or different SCADA softwares into our platform, which are already trial and tested in any particular environment. So this is one of the examples that I have. Like basically what we call management applications is something that, okay, already trial and tested, why do we update? We keep it, bring it over to the different projects. But if we need to develop something, we adopt some different adapters specific to that project. And like I mentioned earlier, we can integrate some already resilient systems into the system while making sure the end-to-end goal is achieved of the product. So Kubernetes, I won't go into that much detail. It gives us benefit of how we roll out the system, how we roll out the changes while having no downtime. So it's one of the technologies we use to ensure if you're upgrading a system from one version to another, like it's seamless. In transport, it's a very big thing to have a tunnel closed, and then you have to arrange all the things around that, and it's very costly. Adopting this solution helps us in rolling out easily. There's other features inside it, but based on time, I will not go in that detail. Another side effect of obviously giving that much flexibility to the development, we have to ensure certain measures are taken beforehand, not later in the stage. Cybersecurity by design, we need to ensure our whole process is following the strict security development life cycle. We are patching based on the changes or dependencies that, for example, there's a vulnerability, we need to be able to patch quickly. We need to be open to integrate with different protocols. And eventually, for compliance purposes, we need to make sure whichever compliance is regulated in that area, we are complying to that. 62443 is very common. We use as our standard, and we make sure we are compliant for that. So in using that, our cyber posture from core to control room is always stronger. Quickly on the human-centered design that we need to adopt, so obviously if a software is built with different languages and everything, you need to ensure at the end user interface is consistent. So very early stage, we have to engage the customer. We need to ensure their requirements are read and understood. And for that, we ensure we follow some well-standard human-centered design guidelines and human factor engineering to make sure that is consistently provided, like the end software is always consistent and is integrated into a single UI that is posed earlier. I think I did touch on the DevOps, like CI/CD DevOps guidelines that we need to ensure. The benefit obviously is faster release, quick, quality gates already in the process, and we ensure that security and reliability is always there when we are rolling out the changes in the live system. So in summary, so this modern OMCS is basically a global technical platform which gives us power and flexibility. It ensures open and secure integration, easy to use modern interface. The entire architecture is modular and flexible that we can basically tailor our tool to just implement what software components we need rather than just having the whole monolith deployed for any particular project. And last, and I think the most important, it's built for tomorrow, and we can integrate with a lot of code development with the different people of the different backgrounds, and we can make sure that AI-based development or modules that are developed are easily integrated and tested in the continuous life cycle before being pushed to the final production systems. I think that's where I will close. These are some key takeaways I have already covered. Some of the use cases we are doing already. So we are actually working in Western Harbour Tunnel project in Sydney, which is a new harbour crossing, and the project using Symphony Urban Mobility in Germany. I hope that's it from my side. Thank you very much.
Great, thank you for coming to that. I have a couple of questions here come in, so those in the audience, keep typing quick. Harris, how do you provide a consistent user experience when the system is divided into separate functional applications? How do you change the user interface when a new application is added? So, like, I touched a bit about the human factor engineering, right? So obviously the point is to engage, like in every project we want to engage the user from the first place, and we ensure that we prototype early in the stage. Yes, there is some fundamentals created, but fundamental UI is something that we need to bring in front of the user. That's what we do. We take their feedback. We take their early in the design concept stage. We ensure like that is adopted into the UI. And once that fundamental is established, then you roll out onto the same other applications. We don't. When I mean by integrating, it's not like I'm integrating a totally separate system into the same OMCS. I'm just developing the OMCS itself. So if I'm providing OMCS as an interface, that's the only thing we will integrate. Obviously, a third-party application will stay outside, and they have their own pre-built user interface. Users are typically accustomed to that. So, yeah. Okay. Another sort of follow-on question: should highway and motorway OMCS transition to an unmanned transport operations center in the future?
Maybe if the AI operator is part of it. It's obviously like sky's the limit, but obviously everything takes time. Nothing happens, all at once. Like you need to take steps. That's the normal path. I think it will take time. I'm pretty sure we will come to that level where AI is operating everything.
Great. So thank you, Harris. Put your hands together again for Harris. Another question we might be able to bring later on in the Q&A discussion when we get to there. So now it's my pleasure to introduce Thomas Simhani, and it's great to have you on board here. I think you spoke last year, is that right?
Yes,
T-Tech,
I did.
I remember that. And he's speaking on EV Maritime, and it's great to have you back a year later and to give us an update of what's happening with the 1 year on successes and challenges of a data-rich electric ferry.
Thank you.
Very good. Thank you.
Hi everyone, yes, my name is Thomas Simhani, representing EV Maritime. Great to be here a year later. And a little bit about our company. So we were founded in 2018, so we're still a relatively new company. And we're the company responsible for Auckland's electric ferry program. We came on right before COVID, and our very first project, as you can see, for Auckland Transport was funded in large part with COVID shovel-ready infrastructure funding, as well as the ECA grant, which was the Energy Efficiency Conservation Authority. Yes, so a lot of unknowns at that time around electric ferries. We're world leading. Not many of these around. Auckland Transport today took control over their first boat, and very soon will take control over our second boat. So it's an exciting time for our company. And I'm going to take this opportunity to just say there were a lot of unknowns at the time, but we were right. It's nice to say it and ring out in the room. About the important things, I think we can say confidently that a year on, a lot of these dreams that we've promised were not dreams and have eventuated. So electric ferries, they work. They're here now. We can build more of them. The charging infrastructure that Auckland Transport has procured works. It's a really impressive kit. These boats are charging at enormous rates. You can almost imagine the lights dimming in Auckland as we're sucking up 2 megawatts of power while we're charging. That's 2 megawatts. Basically, every time the ferry stops and passengers embark and disembark, we'll take a top-up charge there. So yes, 2 for Auckland, but the world took notice. So Auckland Transport at the time was world leading in procurement of electric ferries. Since then, we have sold projects into Perth, so 5 boats into the Perth Transport Authority, and then also 2 clients in San Francisco, a fully foiling ferry version, and then kind of the opposite, a whale watching slow excursion vessel. Interestingly, emissions not the main driver of funding in California, so all of the federal or state funding there is through the Air Pollution Resource Board. A little bit about the boats. So, yep, 24 meters long, and they carry 200 passengers, which puts them about medium size for Auckland. They're quiet, just like an electric bus. They're great boats to be on board. You can hear conversations from the other side, which could be annoying, I suppose. They're so quiet. A little bit after this photo was taken, we actually clocked 30 knots, which in new money is around 55 kilometers an hour. And as far as we can tell, that makes us the fastest electric ferry in the world. And they're extremely capable. Auckland Transport will receive a boat that will primarily service the Half Moon Bay route, but they're capable of doing any route in Auckland, including the harbour, the outer harbour, such as Gulf Harbour or Pine Harbour. And the other thing invisible in this photo is the data side. So yes, boats can also be intelligent transport systems. We're transporting what we think of is an enormous amount of data, so 800 points per second, which translates to 3 gigs a day for a single asset, which is about 1 terabyte a year. The software that does this, I spoke about last year. It's called Deputy, and it serves a few functions. One is sort of the dashboard you would expect from an electric car. You get a tachymeter and some gauge for your state of charge. But it also does some clever calculations to make sure that the operator doesn't run out of charge. We use the schedule and real-time weather conditions, the wind, the waves, tide forecasts, as well as the passenger count to make sure that that the operator doesn't run out of charge. But put succinctly, we didn't want to step on any egos, so the captain is still the captain, and we're just a cute little robot doing calculations in the background. So a few lessons over the last year. I think it's fair to say that one of the things we weren't exactly right on is how long it would take to commission the charging side. Like I said, an enormous amount of power goes in, and to quote Harris, this is a system of systems, and they talk to one another. So we're using a charging protocol from the automotive industry, CCS. Turns out that doesn't work so well in boats when you have your earth ground is a bit fuzzier on the ocean. And so it was a real challenge to get this thing working and get it reliable, which is what Aucklanders expect. What helped? Getting the right people in the room. You know, we heard it this morning, working constructively and methodical testing, which I'll touch on later. Sometimes we had to treat it like a black box. Just feed it a bunch of inputs and see if the same outputs came out. Unfortunately, the truth is not one person understands the entire system from start to end. We got short charging, we got many companies involved, many lines of code. On to fluid dynamics. So one of the dreams we promised was, we'll build the boat in carbon fiber, you know, rely on New Zealand's excellent maritime history, and that allows us to build a much more efficient hull. So we thought our boat would be 30% more efficient than a new diesel boat. And we have the data for diesel boats in Auckland. And what we came out with was that we're even more efficient than that. So at high speeds, we're more than 35% more efficient than a 24-meter diesel boat. And that's despite us carrying 12 tons of batteries on board. How do you prove that when on the water you've always got different wind conditions, different tide? That's where data comes in. Skipping along, data volume. Like I said, we feel like 3 gigabytes a day is a fire hose of data, and we certainly learned a lot on the way on how to manage that. My colleagues came to me with really interesting questions, you know, like, oh, we've got this channel and this channel, can you figure this out for us? Tom and I said, yep, but it'll take my computer 3 hours to crunch the numbers, let alone the setup time, so make sure it's the right question. Since then, we've implemented a few, you know, common sense policies which have really reduced that time down so we can have it onto a web portal. Data partitioning from a SQL table point of view, it's an easy one. Personalized dashboards, so people were asking for, you know, they were asking for the world, but they only needed 2 or 3 different channels to answer their question. And then also time resolution, so giving a downsampled 1 minute sort of increment at the first query and then fetching new data along the way. Lesson 4, UX. This has been covered. I'm super guilty of this. I get so excited and say, look at this new feature. Here's how you do it, you know, bing, bing, bing. That doesn't work. That doesn't work because you're watching the screen and you're not watching the user. So you have to watch the user. And in fact, a lot of the time, their body language tells you more than their words will. They want to be polite and not offend you, but you can tell in their body language they didn't know where to look. They didn't know where the settings button was. Yes, simplicity is difficult. That's a cliche, but we find it to be true. And this is my last point. So software testing configuration. This morning, the phrase of defining success came up. This is how we do it. And we find, yes, hey boss, great, I did the feature and the test passed. That's cool. But writing software is actually quite cheap. Changing software is really expensive. So tests are what allows us to keep changing the software and knowing we don't break any of the commitments that we've made to the clients. And lastly, more of a plea to the industry, we dealt with a very complicated system which had inherent in it default values, which is very common. So we've received a DC-DC current converter, and it had a default value of 300 kilowatts. Turns out in our system that wasn't right, and subsequent firmware updates kept bringing back 300 kilowatts. So what we found works a lot better is, 1, keep your configuration in a single place, but 2, keep it very explicit what configuration is needed, and crash with a good error message saying, you didn't provide the right detail, try again. We find that to be a lot more foolproof. So thank you very much, and great to be here again.
So we have a couple of questions here. How's actual occupancy on the ferries? Could you share the decision-making process to use a 200-seater instead of smaller ferries that may allow the services to be more frequent?
Yeah, that's a good one, and not one I'm involved with. It's more of the client procuring the vessels. Yes, I'll have to kind of pass on that.
Was the decision made for you on the 200?
Yes, yeah, that was part of the procurement. You see this sort of question in the airline industry, you know, hub and spoke versus lots of autonomous or smaller vehicles. In Auckland, I think we just relied on past passenger data, so can't comment too much.
Okay. What is the range of the electric battery on the ferries? Is it realistic for one to operate on a longer route, e.g. Gulf Harbour? Also, is there any talk of upgrading the Waiheke ferry to electric?
Yeah, great. So the range is about 25 nautical miles at full speed. In Auckland, every route tends to go into downtown ferry terminal, so there's a bit of 12-knot zone. So in practice, the range is much higher than that. Yes, our ferries can attend to Gulf Harbour, as well as Pine Harbour, so all the long routes in Auckland, that's capable of doing that today. And then the last part?
Waiheke.
Oh, Waiheke. Yes, and Fuller's, in fact, have said, or their CEO, Mike Horn, has said they will never buy, with their own money, they will never buy another diesel boat, and electric is what makes sense. Waiheke has some charging challenges, so there isn't a large, you know, to get a 2 megawatt charger installed in Waiheke would probably double the capacity of the power going into Waiheke. But there are lots of solutions there, like you can have a battery-assisted charger, which trickle charges some local batteries, and then they dump that energy quickly into a vessel. So we can already go to Waiheke. It's just a matter of fitting into a schedule that makes sense for the operator.
If you went to Gulf Harbour, what would be the capacity left after the longest trip at the moment? So is it depleting down to 10%, or is it, are the batteries, what happens if an incident happens on the way? That sort of risk analysis that would...
Yeah, I believe Gulf Harbour is about 15 nautical miles away.
Okay,
so we do have some spare capacity there.
and is there charging at all ends at the moment, or where's the...
So at the moment, there's a single charger in Auckland.
Right, so you've got to get back.
You've got to get back. Downtown Ferry Terminal will get its charger late this year.
Yes.
And yes, your electric ferry is not going to go very far if you can't charge it. So infrastructure is a key issue, and one that, you know, the government agencies are much better placed to put in place than private sector.
Well, maybe hold that. Let's get the last question. We'll bring some questions towards the end. So put your hands together for So our last presentation of today, hold this between drinks. Yulong. Yulong is from the University of Auckland, and he's going to be speaking on continuous and on-time operation of electric shared autonomous vehicles with dynamic wireless charging. Thank you.
Thank you, Doug. Hello, everyone. My name is Yunlong. Now I'm a PhD student. I'm during my final stage because I almost finished my third year. Yeah, actually, it's my third time to attend the T-Tech conference. And I have to say that, yeah, in each stage, T-Tech gave me a lot of help and asked me to share my recent research progress. So yeah, I quite enjoy that. So today I'm going to share my final stage PhD student research. The title name is the continuous operation about on-time for electric shared autonomous vehicles. So first, what is electric shared autonomous vehicles? Yeah, of course, they can be shared and they are autonomous vehicles. And of course, they have to be the electric vehicles. And in this it's kind of like a vehicle routing problem. During this problem, we introduced not the traditional conventional plug-in charging, but it's the dynamic wireless charging. Yeah. So why we use the dynamic wireless charging? Because the shared autonomous vehicles, the final target, are used to replace or to be a main method in the public transportation system. We hope that they can replace the traditional taxis or buses. So of course they are hoped and expected to run continuously, like the 24 hours or at least more than 10 hours. So we got the first question: if we still use the plug-in charging, that means the vehicles have to stop during the charging stations, and the charging the progress could take 2 hours or 3 hours or quite a long time, and during this time it will lose service time. And then here is the advantage of the dynamic wireless charging. Dynamic wireless charging enable the shared autonomous vehicles, this kind of vehicles, to be charged during the operation when they are driving on this green road, and they can be charged. So it can be understood these vehicles can be charged on time based on this DWC method. Of course, we will get less downtime and more continuous service. Got a better fit for long-duty urban fleets. So here is the problem of what we are going to solve. And from this slide, we can see that the shared autonomous vehicles will start from the depot. And during the depot, maybe they can be charged by the static charging if they are not work. When they start working, they will first pick up some passengers and drop off passengers, and just repeat, and keep working. And of course, because they are electric vehicles, their battery stage, the SOC, the state of battery, like our iPhones, we have the 80%, 10%. Yeah, the SOC, the battery state will decrease. Then we will pass by the dynamic wireless charging segments to recharge themselves. And during this progress, we also need to consider the time windows. The time windows, just like from the perspective of the passengers, we hope that the taxis or the electric vehicles can pick up me or drop me on time. So that will be a key factors relative to the service quality. And so here is more specific scenarios. Like we first pick up passengers at 8 to 8:15 a.m. Then we will find the opportunity around to pass by the dynamic wireless charging road to charge ourselves from the 55% to 80%, maybe just 60%. Anyway, we will be charged, and our battery state, the battery level will increase, and then we will drop off passengers. Also, I want to claim that the charging process can happen during each process, like between the pickup to drop off, between the passengers drop off to another passenger's pickup process. Yeah, and so in this problem, each request have a pickup and a drop off window, and the vehicle must stay safe battery limits. Like if we consider the life for the batteries, from the 30% to 80%, it will be a bastard interval for the battery. That will keep the healthy for the batteries. And so here, if we want to solve this problem, we have to model this problem. During my research, I used the Sumo, which is software. I first extracted Auckland central areas road networks, like the green figures, and then I deployed the dynamic wireless charging road. For my research, I didn't consider how to optimize the locations of the dynamic wireless charging roads, but I considered how to make full use of these roads to do some vehicle routing optimization. So as the figures show, the blue lanes are the dynamic wireless charging road. And why we deploy the dynamic wireless charging road as this kind of roads, because we got the traffic flow data from the AT, and so we select the highest traffic flow lanes and deploy them. Yeah, so it's just like a simplification. Another data site, we have the Auckland, New Zealand taxi data site. We mainly select the Auckland central area, the Wellington, and the Christchurch part of areas to do small different across city scales tests. Yeah, then we propose a very complicated, it's really hard to explain the algorithm detailedly. So I mainly extract them and ask AI help me to give some very brief introductions. First, it's like the ChatGPT's our proposed algorithm, just like the ChatGPT. When we ask ChatGPT, how are you? Like the ChatGPT, I'm pretty good. So first, we will consider how to process the how are you. The how are you means how many SEVs, how many vehicles we have, where are the dynamic roller charging there are, and how many passengers, and where are the passengers. All of the information, like the how are you, are input to our model. And then our model, in the second step, is trying to understand, to process all of the states. Yeah, but this state is quite complicated. I even cannot realize that because it's a lot of the layers of the neural networks. And but anyway, in the third step, we score the choices. Like I ask you, how are you? I'm pretty good. Then I will score the I am pretty good. I will give each course, maybe others, the weather will be good, but the other will be good, but the weather will be good, we will got lower choices, lower scores. So we will not give you a response, the weather, but I will give you, I'm pretty good. Yeah, so that's the choices. The choices will give each potential node, like we have a lot of potential passenger nodes. Then we will give each scores. If we visit this passenger node, then we can pass by the charging roads, and we can also arrive on time to satisfy the passenger's request. Yeah, that's great. That's great. Then we will give a choice. And finally, in the first step, we will filter the bad options. What is bad options? Because we have a lot of constraints. Our SEVs, for example, we only can pick up 6 passengers. But one passenger node, there are 8 passengers or 5 passengers, are more than our capacity. So we have to filter them. And also, if one of the nodes are quite far away from my position on my SEV, then it will cause a lot of the battery antigen. And when we arrive there, maybe the SOC, the battery state, will be very low. Then we have to filter that out, maybe ask another SEV to pick up them. Yeah, so finally, we will choose the next stop. So from the step 1 to step 5, we just finished the one process. That means we only output one node. And then we repeat the whole progress. And finally, we got a sequence. The sequence means first pick up passenger 1, 3, 5, 6, 9, 8, 2. Yeah, like this sequence, node sequence. Yeah, during this page just showed the constraints. Like during this progress, we consider the battery safety. The first figure shows is if the SOC, the state of charging, will be very lower, then this kind of the solutions will be masked, will be deleted. And then the passenger time windows, if we arrive late or early, it's not good. We have to select some nodes we can arrive on time and just do some coordination between all of the potential vehicles to ask them to work together. And then it's the vehicle capacity and dynamic opportunities. So it's just like we first got a lot of the candidate actions. Then we use this filter or constraints to find some feasible actions, then to optimize them. So here's the potential outcomes or results for our algorithm. Yeah, the blue bars shows that, yeah, across our proposed method are the best, and we'll compare with other AI models. So I will brief summarize that is from the perspective of on-time ratio, the route cost, the travel distance, the travel time, yeah, our proposed algorithms are the best. And here are the 5 key interesting conclusions. First of all, we can use this method, we can prove that, make sure all of the SEVs can pick up passengers about 90% of on-time ratio. And more interesting is that we can only use 29 SEVs, shared autonomous vehicles, to replace the conventional vehicles. Because we can use the dynamic reverse charging road, we do not need to stop for charging. That we can reduce a lot of congestions because, yeah, this kind of ratio. And the coverage ratio of the dynamic wireless charging road are only 5.5, and the power level is from the 25 to 50 kilowatts are enough. And very most importantly, and we can reduce the battery capacity. Because for the conventional and traditional taxis, they have to pick up on the load of very large capacity, like more than 50 kWh. Yeah, but the larger capacity means a larger weight and larger energy consumptions. But using this method, because the vehicles can be charged during the driving, then we do not need to carry a large battery. Yeah, that's great. And what does this mean? So for fleet operators, that means we can improve the got a higher vehicle utilization because the vehicles can run continuously. Yeah, our research have proved that using this AI method, it can run continuously for 24 hours, do not need to stop. But of course, if there is no passengers, we have to stop. And also, the fewer vehicles for the same demand and the less charging downtime. For the cities, because we can use the lights as EVs to replace the taxis, so that means the less congestion and the better use of the electrified roads and more sustainable shared mobility. For passengers, yeah, because we can prove and make sure the SUVs arrive on time, so it can totally satisfy the passengers, and the better on-time performance and the fewer service interruptions. Yeah. So that's all my research and report for today. And so here is the paper we just published on the Transportation Research Policy, which is a top journal in our area. So welcome to accept that if it is useful for you. And here are my linking and the Google Scholar. Yeah, if you think my research topic are interesting, please scan that. Yeah, thank you. Thank you, Eric.
Thank you, Yunlong. And maybe can I call up the other speakers up to the front here while we're just asking a couple of questions. Oops. You stay there at the moment. We'll have some speakers. I've just gone and changed the wrong room, and we'll get back to it. Sorry, I clicked the wrong button, went to the wrong room, and looking at questions in the wrong room. Doesn't help.
No, thank you.
So, Yunlong, first question. At the early stage of DWC, which is Dynamic Wireless Charging Systems deployment, is there a risk of creating congestion related to charging?
Yeah, I do agree, yeah. Actually, during my research, I just deployed the dynamic charging node on the highest traffic flow areas. But that's caused another problem. If it's already the highest traffic flow segments, that means there could be a lot of the congestion. So in the early stage, I have to do a lot of tests. The first one scenario is deployed on the highest traffic flow segments. Another area is a combination of the motorways, also the expressways, also considering different speed limitations, like from 10 kilometer per hour and 50 or 80. So I think I need to do further exploration to try or take a test which kind of the combination or how to deploy the dynamic charging road that can introduce or guide the drivers to try different roads to reduce the congestion. I think it's also the one of the advantage of the dynamic charging road, because if we can use the lower electricity price to guide the drivers to other areas, maybe then we can reduce the congestion. Yeah.
And another question, presumably in order to work, the shared autonomous vehicles, SAVs, will need to drive on specific roads where DWC infrastructure is installed. So what makes this a better option than just adopting the same technology on a regular bus route?
Oh, yeah, I do agree, yeah. I think either a better or the best choice for the DWC, it could be in the city areas also there is a strict limitation for like the bus lanes only for buses, but for other areas like the suburbs, it could be shared for the buses, for the autonomous vehicles. Yeah, I do agree. And but there is another consideration is that for the buses, we have other friends work. They show that the power level could be the 17 kilowatts to the 125 kilowatts. But for the SEVs, we only need to like a low level, for example, the 20 to 50 kilowatts. So there is some industry or technical problems. If we can solve that, yeah, I quite encourage all of the SEVs and the buses share the same rules to reduce the investment to the DWC deployment. Yeah.
Okay, put your hands together for Yun Long and
Yeah,
join the seat. Thank you. Okay, there are some other questions in here that we didn't cover, and I'm going to try to figure which ones we haven't covered. But I might actually open up. You had a question here of Harris, was it? Or?
It was for the EV ferries. Ferries have a very long asset life, 20, 30 years. So how long will the batteries actually last?
Yeah, great question. And in fact, a carbon fiber ferry, we think the hull will last 50 years, as opposed to an aluminium ferry which has work hardening. So all these ferries are driven really hard by the operator. They're running sometimes 18 hours a day. And so they're actually getting their internal combustion engines replaced every 5 years. We are now at the point where we can offer a warranty on the batteries, let alone replacement, for 7 to 8 years, or 9, depending on your use case or your use profile, right? So that's a rough ballpark for you, like 8 to 10 years is how long the batteries will last. It's probably a bigger cost to upgrade the batteries than it is to upgrade the motor, but you do it less often.
Follow-on question from that on Slido, which is what is the battery size kilowatts of reduce the kilowatt hours of ferries used and the charging time for that? And also do ferry do top-ups during trips?
During trips, yeah, we'd love to have a DWC for the ocean, charged through the waves. So our ferries in Auckland have just over 1 megawatt hour of batteries on board. That's 12 tons split over the 2 hulls. Yes, we do charge during passenger embarking and disembarking, and the charges put in by Auckland Transport are capable of up to 3 megawatts of charging. So we can charge faster than we discharge, which means that, take the Half Moon Bay trip, it's a 35-minute journey, and there's 10 minutes in the schedule for passengers embarking and disembarking. In that 10 minutes, we can take up 80 to 90% of the energy of the 35-minute journey. So we don't quite catch up to kind of an infinite cycle, but on the Half Moon Bay trip, we can replace the vast bulk of the energy just during normal operations, and crew breaks and so on would let us have a longer charge period to catch up.
I'll go back to here. Might be easier. Stacey, there's been debate over whether low or no transit fares actually get people out of cars and onto transit, as opposed to approaches like increased frequency and reliability. Are there any results coming out of Queensland/Australia that show how the fare changes have gone?
Yeah, this highlights the difference between self-reporting and revealed preference. People say they want cheaper fares, but it doesn't really make that much difference. So these are really interesting natural experiments happening. The timing has been interesting. The 50-cent fares in Queensland was a previous government election promise, but now it's been established to be permanent. So I think it's going to take a bit of trust to get people, okay, it's going to be 50-cent ongoing, so I can start to rely on it. They are seeing a pretty interesting increase in opportunistic trips. If it's only 50 cents, we'll just jump on the tram and go to the Gold Coast or up to Sunshine, or catch a bus to Sunshine Coast. So that is increasing. In Victoria, they've only just made the half-price fares permanent-ish. So I think it's going to take a little bit more time to see what gets people out of their cars. What we did see, though, when the train from their Southern Cross to Ballarat and Geelong dropped to $9, it was standing room only within the day. So people are very price sensitive, but it needs to be consistent, reliable, and increasing service levels. Like a timetable-free service is always going to get you better capacity and better patronage than dropping the price. We talked earlier, like I know in New South Wales, like some of our ferry trips are $50 to $70 per person per ferry. So it's so subsidised that increasing the patronage is better than reducing the cost.
Great. For the Engineering X team, so that's James and Hanwei. How does Engineering X incorporate terrain data into the design process? Do you optimize the vertical alignment and road gradients automatically, or do engineers refine those manually afterwards?
So basically, for this one, we have to honestly say that it is part of our roadmap. So currently, we use vehicle tracking, we use spatial constraint to automate for 2D. And the next step is going to be the crossfall, it's going to be the vehicle vertical alignment, and all these will be incorporated. And we envision a process that engineer actually understand 90% of the site layouts first, and that's what the client wants to know, because in the site, you cut back or not, you build out or not, these are the first information site layout that your client wants to know. And after that, 90% of the site layout confirmed, that's the next step to be thinking about the utilities, thinking about the terrain data, and that's why it's part of our roadmap.
So you're doing a plan view optimization first, and then you'll consider the spatial terrain later. Does that works for relatively flat terrain? Much more difficult than if you're not combining that in the process with much more steeper terrain. Would that be right? So there might be an iterative process that you would need to go when you bring in the terrain to modify your plan.
Correct. Because currently the product is aiming for early design stage, where you probably don't even have a terrain data to start from. So easily the client can get GIS data from Council GIS to actually automate design and cost, and engineer make decision about what sort of design rate and cost to use for the cost estimate. That gains the early design cost certainty, and terrain data definitely is feasible to be inputted into the software, and sometimes you get a flatter site, then all you care about is widening. But if you get a steeper site, and that's more consideration of our coordination of our engine for the vertical alignment and also the crossfall, these are the consideration. And we have a bunch of R&D engineers currently is prototyping, investigation into these sort of capability, and the software is capable to future-proof for those capability.
Right. And I know we're getting very close to time to getting drinks, so I don't want to hold you too much from that, but a question for Harris in regards to how does OMCS prioritize conflicting objectives, such as minimizing congestion while maintaining public transport priority and pedestrian safety?
Well, nice question. I think mainly it depends on ensuring that this is most likely a functionality we consider part of incident management, right? So we develop a system to do some pre-analysis. Like, it's not like we are developing an incident management system which is doing this congestion, and we develop something we call prioritization-based traffic control. So it really depends on, there's a level of simulations, there's a level of pre-evaluation you need to do before you can actually confidently say that there's not going to be any congestion, because in real-world scenario, we have seen that system like OMCS can have too many parameters, which creates it difficult to identify all those scenarios. So it's really a matter of designing the system in a way that you ensure like system you're using for typical incident management has certain behavior, and the system you're designing for the priority of the buses over the other traffic is not conflicting throughout the process, you cannot just at the end rely on the system itself to ensure that. That's why operator is very essential in the middle to ensure, like, after you do all that due diligence, there's still some risk left. So, but again, that's the reality. There's always some level of risk, and we have to ensure throughout the life cycle of the process, like, that risk is mitigated one way or another.
And a final question for Toma, given that a good one to finish what to go to drinks. The Half Moon Bay electric ferry appears to be a success, but Auckland Council still ordered diesel-powered hybrid ferries. What was the stumbling block stopping total adoption of electric?
Yeah, good question for Auckland Transport. I think Auckland Transport should buy 100 ferries from us. I think timing was a bit, just the luck of the draw. Our project overran by a year and a half, partly because a battery supplier went bust and we needed a new design, partly because COVID delays. So just the way that cookie crumbled and the cards fell with asset management replacement has been a factor. Naturally, I would say that that's a short-sighted decision, but what I hear from the official line, which has a ring of truth to it, is that government, central government funding, which was available in the first project, has dried up for the second project. So that's part of our industry, is we're heavily influenced by public funding. And that's what happened.
Yes, the business we work in. So thank you very much. If you can put your hands together for everybody for the speakers this afternoon. We've got a full-on afternoon, full day. I do want to invite you to the Q3 networking drinks. So down in the level 3 around the exhibition area, Q3 sponsored networking drinks. And those of you that are registered to come to the dinner tonight, remember that starts at 6:30 over in the Pullman Hotel. There will be a walking tour from here to there, which is only about 10 minutes away, so don't have to catch an Uber unless it's pouring with rain. Haven't looked out, it's pretty dark. We can walk through the university to get to the Pullman Hotel. So 6:30 there'll be a walking tour leaving to go to dinner. All right. Thank you everybody for coming today. Hope you've enjoyed the day, and we look forward to seeing you at drinks.